Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on solving equations, and we're going to be looking at more advanced equations, so fractional ones. If you need any extra help in this topic, if you go to Corbettmaths and go to videos and worksheets, and you scroll down to video number 111A, there's a dedicated video tutorial on these types of equations. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1, we've been asked to solve 2 over x plus 2 over x plus 3 equals 1. So if I wanted to solve an equation like this, what I would do is I would work out the left-hand side to begin with. I would simplify this left-hand side. I would add together these two fractions. And then once I've added together the two fractions, then I'll deal with solving the equation. So let's add together this left-hand side. So let's work out what 2 over x plus 2 over x plus 3 is. So whenever adding fractions, think back to your algebraic fractions, and if you haven't watched the Corbettmaths video on algebraic fractions and how to add and subtract algebraic fractions, I highly recommend you look at that one. So if we wanted to add algebraic fractions like this, what we want to do is we want to get a common denominator. So we're going to multiply both the numerator and denominator of this fraction by x plus 3, and we're going to multiply both the numerator and denominator of this fraction by x, and then that'll give us the same denominator for both fractions. It'll be x times x plus 3. So let's start off by multiplying both the numerator and denominator of this fraction by x plus 3. So if we multiply the numerator by x plus 3, I'm actually just going to write it in a bracket. So I'm going to write 2 bracket x plus 3, close brackets. That means 2 times x plus 3. That's timesing the 2 by x plus 3. Some people might just want to go and write 2x plus 6, but I would probably write it in a bracket to begin with, and I'll expand the brackets later on. So that's what we get if we multiply the numerator by x plus 3. Now we're going to multiply the denominator by x plus 3. So that'll be x and then in brackets x plus 3. So we've multiplied both the numerator and denominator of this fraction by x plus 3. Now we're going to multiply both the numerator and denominator of this fraction by x. So 2 times x is 2x. And then on the denominator, we've got x plus 3. We're going to times it by x. We could write x plus 3 in brackets and then put the x after it. I would write it the other way around and put the x at the front, so x bracket x plus 3. So if we're timesing x plus 3 by x, you could just put it in brackets and put the x in front. And as you can see, we've got the same denominator there. We've got a common denominator. That's fantastic. And then we need to put r equals 1, because remember, it's an equation and we still have that right-hand side of the equation. Okay, so we've now got two fractions with the same denominator. Now we need to add them together. And remember, if you're adding fractions together with the same denominator, it's quite nice. You just add the numerators together. Now, actually, at this point, just before I do the addition, I'm going to expand the brackets. So in terms of this numerator, 2 times x is 2x. And then 2 times 3 is 6, so plus 6. So if you expanded these brackets, you'd get 2x plus 6. And then we've still got the denominator of x bracket x plus 3. And then we're adding 2x over x bracket x plus 3 equals 1. So what we've done there is we've just expanded the brackets because we're now going to add together the numerators, and it's just a little bit easier once you've expanded the brackets. Okay, now let's add together the numerators. We've got 2x plus 6 and we're going to add 2x. So we're going to add the x's together. 2x plus 2x is 4x, and then we've still got our plus 6. So if you add these numerators together, you'd get 4x plus 6. So let's write that, 4x plus 6, and that's going to be over our denominator of x bracket x plus 3, close brackets. And we've still got that equal to 1. So that's fantastic. We've now added together these fractions to get 4x plus 6 over x bracket x plus 3, close brackets, equals 1. Okay, so that's fantastic. Now we want to solve this equation. Now there's a few different approaches we can take at this point. What's interesting here is it equals 1. Now, if you've got a fraction that equals 1, the numerator is equal to the denominator. So it's possible at this point to just write 4x plus 6 equals x bracket x plus 3, close brackets. Because you know if it equals 1, the numerator equals the denominator. So you could jump straight to that step if you spot that. Alternatively, and I'm going to use the more general approach to solving these, here we've got a fraction equals 1. I want to get rid of the denominator because it'd be great if we could solve the equation where there weren't any x's on the denominator. So I'm going to multiply both the left-hand side of the equation by x bracket x plus 3. I'm going to multiply the right-hand side of the equation by x bracket x plus 3. And that will give us on the left-hand side, we're multiplying by x bracket x plus 3 to get rid of the x bracket x plus 3 on the denominator. So we're just going to be left with, I'm going to go up here, 4x plus 6. We're doing it to get rid of that divide by. And on the right hand side we had 1. We're timesing it by x bracket x plus 3, so it's going to be equals x bracket x plus 3. And so that's fantastic. We've got rid of the x's on the denominator. Now actually one thing I did mention was that bit of a shortcut, the fact that it equaled 1, that the numerator equals the denominator, and that's what we've got there. Okay, now we want to solve this equation, so let's expand the brackets. So we've got 4x plus 6 equals x times x is x squared, and then x times 3 would be plus 3x, just expanding the brackets. Okay, so we've now got to this stage. Now, this is a quadratic equation. So we want the quadratic to equal 0. So we've got the x squared being positive on the right-hand side here. So let's get rid of this 4x plus 6 on the left-hand side to leave us 0 here. So let's take away 4x from both sides to begin with. So if we take away 4x from the left-hand side, we'll just be left with 6. And then the right-hand side, we had x squared plus 3x, but we're taking away 4x, that'd be minus 1x, or just minus x. And then finally, we want it to equal 0, so let's take away 6 and take away 6. So on the left-hand side, we're going to have 0, and on the right-hand side, we're going to have x squared minus x minus 6. So that's fantastic. We've now got a quadratic equation. Now, it's a non-calculator question, so hopefully this will factorize and we'll be able to find our possible values for x. So in terms of the right-hand side, if we factorize it, so bracket, 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 we've got x in front of both brackets. Now, we're looking for two numbers that will multiply together to be -6 and add together to be -1, so minus 1x there. So two numbers that times together to be -6 and add together to be -1, I'm thinking -3 and 2. So -3 times 2. -3 times 2 is -6. And -3 plus 2 is -1. So that's fantastic. Okay, so we've now got our two brackets timesing together to be 0. So that means that either the brackets are equal to 0. So that means that either x equals 3, that would work, 3 minus 3 is 0, or x equals -2, because -2 plus 2 is equal to 0. So that means our possible solutions, or possible values for x would be x equals 3 or x equals -2. Some people write and there, I like to write or, it's just my own preference. And that's it. So there are two solutions, x equals 3 or x equals -2, or some people write and. Okay, and let's just check our answers. If x was equal to 3, you would have 2 over 3, 2/3, plus, and then 2 over, and then 3 plus 3, 6, so that's 2/6, and 2/6 cancels down to be 1/3, so you end up with 2/3 plus 1/3, and that's equal to 1. So that works. If x was equal to -2, you'd have 2 divided by -2, that's -1. So that's -1, just going to write there, -1. And then here, if x is equal to -2, you'd have -2 plus 3. -2 plus 3 is 1. 2 divided by 1 is 2. So you end up with -1 plus 2, and that's equal to 1. So that works. So there are solutions. And that's it. We've done that question. Okay, let's look at our next question, question number 2. So question number 2, we've been asked to solve 1 over x plus 3 plus 6 over x plus 7 equals 1. So again, we're going to add together these algebraic fractions to begin with. So we're going to simplify this left-hand side, and then we'll solve the equation. So to add together these algebraic fractions, what we want to do is we want to get the same denominator. So we're going to multiply both the numerator and denominator of this fraction by x plus 7, and both the numerator and denominator of this fraction by x plus 3. So let's do that. So if we times the numerator by x plus 7 of this fraction, well, 1 times x plus 7 would just be x plus 7. And then on the denominator, we had x plus 3. We're going to times it by x plus 7, so we're going to have x plus 3, bracket x plus 7. Remember, if you just put two brackets beside each other, it means to multiply. So we've multiplied both the numerator and denominator of this fraction by x plus 7. Now what we're going to do is we're going to look at this other fraction, and we're going to multiply both the numerator and denominator of this fraction by x plus 3. So we've got 6, and we're going to times it by x plus 3. So I'm just going to put in brackets x plus 3 there. I could expand if I wanted to. I'll probably do that as my next step, but I'm just going to put them beside each other at the minute to say it's 6 times x plus 3. And then in terms of the denominator, I've got x plus 7, and I'm going to times it by x plus 3. Now remember, with multiplication, it doesn't matter what order you do it in. So I'm actually going to do the x plus 3 at the front, just so it looks like the other one, x plus 3 brackets x plus 7, because I've just taken the x plus 7 and times it by x plus 3, and I've just put the x plus 3 in front of it. So it looks like the other one, and that equals 1. So we've got the two fractions with the same denominator. Now we need to simplify them, so we need to add together the numerators. Now before we do that, let's expand the brackets here on this fraction here. So this fraction will stay the same, x plus 7 over brackets x plus 3 bracket x plus 7. Then we've got our other fraction. Let's expand the brackets. 6 times x is 6x, and 6 times 3 is 18, so plus 18. And that's all over x plus 3 brackets x plus 7, close brackets. And that equals 1. So we just expanded the brackets there. Now we've got two fractions with the same denominators. Now let's add together the numerators. So if we add together the numerators, x plus 6x is 7x, and 7 plus 18, well, 7 plus 18 is 25, so plus 25. We've just added together the x's, which is 7x, and added together the 7 and 18, which is 25. And that's all going to be over our denominator of x plus 3 brackets x plus 7. So we just added together the numerators, and that equals 1. So we've added together the fractions. Now we've got a fraction equals 1. Again, because it equals 1, we know that the numerator equals the denominator, so we could jump straight to that step. Alternatively, here what we've got is we've got a fraction with some x's on the denominator. We don't want those, so let's multiply both the left-hand side and the right-hand side by the denominator of the fraction, and that'll get rid of the denominator. So let's multiply the left-hand side by x plus 3, x plus 7, and multiply the right-hand side by x plus 3 and x plus 7. And when we do that, we get the left-hand side. Well, we're multiplying by the denominator to get rid of the denominator, so we're going to be left with 7x plus 25. And on the right-hand side, we're at 1. We're timesing it by x plus 3 and x plus 7, so it'll just be x plus 3 and x plus 7. And as I mentioned, we've got the numerator equals the denominator. Now let's go up here. So we've got 7x plus 25 equals brackets x plus 3 and x plus 7. Okay, so now we want to solve this equation, so let's expand the brackets. So the left-hand side will stay as 7x plus 25. And the right-hand side, when we expand the brackets, x times x is x squared, x times 7 is plus 7x, 3 times x is plus 3x, and 3 times 7 is plus 21. And if we simplify this, we're going to get 7x plus 25 on the left-hand side, and on the right-hand side, the 7x plus 3x, that's plus 10x plus 21. So we just simplify that by adding the 7x and the 3x together. Okay, now here we've got a quadratic equation. We want it to equal 0, so let's take away 7x and take away 25 from both sides of the equation. So let's start by taking away 7x's from both sides. So the left-hand side will just be left with 25, and on the right-hand side we'd have x squared. With 10x, we're taking away 7x, that'll be plus 3x, and then we've got plus 21. And then we want to get rid of the 25, so let's take away 25 and take away 25. So the left-hand side will be 0, which we want for our quadratic equation, equals x squared plus, we've still got our 3x, and then we have 21, take away 25, so it's going to be minus 4. So this is fantastic. We've now got this quadratic equation. Let's hopefully factorize it, and it's a non-calculator question, so fingers crossed it will factorize. So x and x. Now we want two numbers that times together to be negative 4 and add together to be 3. So I'm thinking plus 4 and minus 1, because 4 times minus 1 is minus 4, and minus 1 plus 4 is 3. So that means that either, in terms of this bracket, to make it 0, x will equal minus 4, or in terms of this bracket, x will equal 1. And that's it. There are solutions. X is equal to negative 4 or x is equal to 1. And again, you can check your answer if you get those values and substitute it into the original question. So for instance, I'm just going to do 1 here. If we had 1 over 1 plus 3, well, 1 plus 3 is 4, so you've got a quarter. And then you get 6 over 1 plus 7. 1 plus 7 would be 8. 6 over 8 is 3 quarters, so you end up with a quarter plus 3 quarters, which is 1. So you know you're right. And then if you do minus 4, you find it works as well. And that's it. Okay, let's look at our next question, question number 3. So question number 3, again, we've got two fractions added together equals a number. So we're going to add together the two fractions and write it as one algebraic fraction, and then equals 2. And then we'll be able to solve that equation nicely. Okay, so we've got 1 over x plus 3 plus 3 over 1 minus x equals 2. So let's multiply both the numerator and denominator of this fraction by 1 minus x, and the numerator and denominator of this fraction by x plus 3. Okay, so let's start off by multiplying both the numerator and denominator of this fraction by 1 minus x. So we've got 1, we're going to times by 1 minus x, well, it'll just be 1 minus x. And then in terms of the denominator, we had x plus 3, we're going to times it by 1 minus x, so we'll just put those in brackets, x plus 3, and then in brackets 1 minus x. Okay, so we've multiplied both the numerator and denominator of that fraction by 1 minus x. Now we're going to multiply both the numerator and denominator of this fraction by x plus 3. So we've got 3, and we're going to times it by x plus 3, and I'm just going to put it in brackets. We can expand it in a minute. And then we've got our 1 minus x, we're going to times it by x plus 3. Instead of writing 1 minus x in brackets and then x plus 3, we're going to write them the other way around just so it matches this fraction. So we've got x plus 3 and then in brackets 1 minus x. Because remember, when you multiply two numbers, it doesn't matter what order you multiply them in. And that still equals 2. Okay, now let's expand these brackets up here. So we've got 1 minus x and then over x plus 3, brackets 1 minus x, and then plus. And if we expand these brackets, 3 times x would be 3x, and 3 times 3 would be plus 9. And that's still over x plus 3, and then in brackets 1 minus x. And that's equal to 2. Okay, so now we've got two fractions added together with the same denominator, so we can just add the numerators together. Okay, so let's actually deal with the x's to begin with. We've got minus x, so this is a minus x plus 3x's. Now if you've got minus x or minus 1x and you add 3x's, that would leave you with 2x's. So that would be 2x's. Then we've got 1 plus 9. and 1 plus 9 is equal to 10, so plus 10. So adding these two numerators together will give us 2x plus 10. And let's just check that. Minus x plus 3x would be 2x's, and 1 plus 9 is equal to 10. Okay, and then our denominator would be x plus 3 brackets 1 minus x, and then that's equal to 2. So we just added together those fractions. Okay, now if we have a look here, we've got our algebraic fraction equals 2. It'd be good if we didn't have this denominator, so let's multiply both the left-hand side of the equation and the right-hand side of the equation by the denominator. So that's going to be multiplying both the left-hand side of the equation and the right-hand side of the equation by x plus 3 in brackets 1 minus x. So multiplying the left-hand side by the denominator, we'll just get rid of the denominator. So we're going to be left with 2x plus 10. So I'm just going to go up here and write 2x plus 10. And then on the right hand side we had 2, and we're timesing it by x plus 3 and 1 minus x. So we're going to have our 2, and then in brackets x plus 3 and 1 minus x. So we've got our 2 there, and we're multiplying it by what the denominator was. So there's 2 brackets, so we've just written it out there. Okay, so now we want to solve this equation. There's a few different things we can do at this point here. One thing we could do is expand our brackets, so expand the 2 brackets, then get the answer and times it by 2, and then sort of work and solve the equation. One thing I've noticed here is that we've got this 2 in front of the 2 brackets, and I don't really like that 2 being there. Ideally, I want to get rid of that 2, because we've got this bracket times 2. But I've also noticed that both of these terms are divisible by 2 as well. We can divide actually both sides of the equation by 2. So let's divide the left-hand side of the equation by 2 and the right-hand side of the equation by 2. So the left-hand side of the equation, we had 2x plus 10. We're going to divide that by 2, so half of 2x is x and half of 10 is 5. So if we divide 2x plus 10 by 2, we're going to get x plus 5. Now in terms of the right-hand side of the equation, we've got 2 times this times this. Now we don't want this multiplied by 2, so to get rid of this times by 2, we're dividing by 2. So we'd just be left with the 2 brackets. So we just divided both sides of the equation by 2. Dividing by 2 on the right hand side gets rid of this timesing by 2. And dividing the left hand side of the equation by 2, well, we just need to divide all the terms by 2. And now we've got to this. Now I just want to point out at this point, if you wanted to, you could expand the 2 brackets, get that answer, times it by 2, and then bring everything over to one side. And I believe if you go to Corbettmaths and look at the answers, that's what I've done. But sometimes whenever you're dealing with questions, you can approach them in different ways. And whenever I looked at this, I just thought it was more natural to divide both sides of the equation by 2. But you could if you want to expand the brackets. And if you expanded the brackets, you get, I'm just going to check the answer on Corbettmaths, you get 3 minus 2x minus x squared. And then if you times that by 2, you get 6 minus 4x minus 2x squared. And then you've still got it equal to this. And then if you bring it all over to one side, you're going to get 2x squared plus 6x plus 4 equals 0. And then you can divide everything through by 2. But we've just divided by 2 to begin with. It just gives us slightly easy algebra to deal with. Okay, so now let's solve this. So let's expand the brackets. So the left-hand side will stay as x plus 5. And on the right-hand side, we've got x times 1. That's going to be x. X times minus x, that's going to be minus x squared. 3 times 1, that's going to be plus 3. And then 3 times minus x will be minus 3x. So we've just expanded our brackets there. And let's simplify it. So the left-hand side will stay as x plus 5. And the right-hand side will be, we've got x minus 3x. Well, x minus 3x would be minus 2x. And then we've got our minus x squared. And then we've got our plus 3. So we've just taken the 3x's away from the 1x to leave us with minus 2x. Now if we have a look here, this is a quadratic equation. Ideally we're going to have x squared and so many x's and so many numbers equals 0, but the x squared is positive. Now here the x squared is negative, so I'm actually going to get rid of everything on the right hand side of this equation. So I'm going to add x squared to both sides to begin with. So on the left hand side we'd have x plus 5 plus x squared, or you could put the x squared at the front, so x squared plus x plus 5, just adding x squared to that left hand side. On the right hand side we added the x squared to get rid of it, so we're left with minus 2x plus 3. Now I'm going to add 2 x's to both sides. So the left hand side will be x squared plus 3x plus 5. And then we've got that's equal to 3 because we've added 2x to get rid of the minus 2x. And now we just need to take away 3 and take away 3. And that leaves us with x squared plus 3x. We had 5, we're taking away 3, that's going to be plus 2 equals 0. And hopefully now we can factorize this. It's a non-calculator question, so hopefully we're not going to be using the quadratic formula. So x and x is the front of both brackets. We're looking for 2 numbers that times together to be 2 and add together to be 3. So it's going to be plus 1 and plus 2. So we're almost there. To make the bracket 0, we need to then consider what x would be. So x would be equal to minus 1 to make that bracket 0, or this bracket 0, x would be equal to minus 2. So there are 2 solutions, that x is equal to negative 1 or x is equal to negative 2. And that's it. Okay, let's have a look at our next question, question number 7. So question number 7, this time is to subtract rather than an add. So it's going to be the same process where we get the same denominator. When they both have the same denominators, we're going to take away the numerators and then we'll just carry on as usual. So let's get both fractions to have the same denominator. So let's multiply both the numerator and denominator of this fraction by x plus 2. So multiplying the numerator by x plus 2 would be 7 brackets x plus 2. And then multiplying the denominator by x plus 2 would be x bracket x plus 2. So we've just put the x plus 2 in brackets and put them both beside the 7 and the x. And then we've got to take away. Don't accidentally change that to a plus or anything like that. Be careful. Sometimes whenever marking students' work, I can see that they've actually just changed it from a minus to a plus. And then here we're going to multiply both the numerator and denominator of this fraction by x. So 2 times x would be 2x. And then multiplying the denominator by x would be, well, let's put it in brackets. So it's going to be x bracket x plus 2. You could, if you wanted to, put x plus 2 in brackets and then have the x after it, but I've just wanted to match the other denominator. And then that's going to be equal to 3. Okay, so we've now got two fractions where they've got the same denominators. Let's expand the brackets here just to make it a little bit easier. So 7 times x would be 7x plus, and then 7 times 2 would be 14. And then let's write it out again with the same denominators. So x bracket x plus 2 minus 2x over x bracket x plus 2 equals 3. Okay, so now at this point we've got two fractions with the same denominators and we're taking them away, so we're going to take away the numerators. So we're going to take away the 2x from the 7x. 7x's, take away 2x's is 5x's, and then we've still got our 14, so plus 14. And then the denominator will be the same, so it's going to be x bracket x plus 2, and that equals 3. Okay, so we're nearly there. Now, if we have a look here, we've got this algebraic fraction equals 3. Well, we don't want this denominator here, so let's multiply the left-hand side of the equation by x bracket x plus 2 and multiply the right-hand side of the equation by x bracket x plus 2. So on the left-hand side, we're multiplying by this denominator to get rid of this denominator, so we're just going to be left with 5x plus 14. And on the right-hand side, we had 3, and then we've got our x bracket x plus 2, so x bracket x plus 2. So just putting that beside the 3. Okay, so now what we're going to do is let's expand the brackets and solve this equation. So expanding the brackets, we've got 5x plus 14 on the left-hand side. 3x times x would be 3x squared, and 3x times 2 would be plus 6x. Just expanding those brackets. Now we're almost there. We want this to equal 0, so let's take away 5x's from both sides. So take away 5x's and take away 5x's. On the left-hand side, we'll be left with 14. On the right-hand side, we'd have 3x squared. We had 6x's, we're taking away 5x's, so that's going to leave us with 1x, or just plus x. And then finally, we want to get rid of the 14, so let's take away 14 and take away 14. So we're going to get the 0 equals 3x squared plus x minus 14. And now we just need to factorize this, so bracket, 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 bracket. So hopefully this factorizes, and I've put 3x in one bracket and an x in the other. And this time we want to find two numbers that times together to be minus 14, and when we expand the brackets, we're going to be left with plus 1x. So I'm thinking a 2 and a 7, perhaps a minus 2 and plus 7. And let's just check that. 3x times x is 3x squared. 3x times minus 2 would be minus 6x's. And then plus 7x's would be plus 1x, great. And then 7 times minus 2 would be minus 14. So that's fantastic. Okay, now we want the brackets to equal 0. This one's easy. X is going to be equal to 2. Or, for this bracket, I'm actually just going to write out an equation here. 3x plus 7 equals 0. So whenever I've got here something instead of just an x, I like to put the bracket equals 0. We're going to take away 7 from both sides to get 3x equals minus 7. And then divide by 3 to get x equals minus 7 thirds. So x would be equal to minus 7 thirds, or x is equal to 2. And that's it. There are two solutions. And let's have a look at our next question, question number 5. So question number 5, we've been asked to solve 7 over x plus 2 plus 10 over 2x minus 5 equals 3. Okay, so just like the others, let's add together these fractions on the left-hand side of the equation. So let's give them a common denominator by multiplying both the numerator and denominator of this fraction by 2x minus 5, and then both the numerator and denominator of the second fraction by x plus 2. So if we multiply both the numerator and denominator of this fraction by 2x minus 5, we'd get on the numerator 7, and then in brackets 2x minus 5. And then on the denominator we had x plus 2, and then we're multiplying that by 2x minus 5. So we've multiplied both of these by 2x minus 5. And then we've got our plus sign, and now we're going to multiply both the numerator and denominator of this fraction by x plus 2. So we're going to have 10, and then in brackets, x plus 2, close brackets. And then on the denominator, we could write 2x minus 5, and then in brackets, x plus 2. But we wrote them this way around for this fraction, so let's write them the same way around. So x plus 2, and then in brackets, 2x minus 5. And then that all equals 3. Okay, so we've now got two fractions with the same denominators. Let's expand the brackets to find out what the numerators would be. 7 multiplied by 2x would be 14x. And then we've got 7 times minus 5, so that's minus 35. And then that's all over x plus 2, 2x minus 5. And then in terms of the second fraction, we're multiplying both of these things in the brackets, the x and the 2, by 10. So 10 times x is 10x, and then 10 times 2 would be plus 20. And then we've got our denominator of x plus 2, and then in brackets 2x minus 5. And then that all equals 3. Okay, so we've now got two fractions with the same denominators, and we've expanded the numerators. So let's add the numerators together. So we've got 14x plus 10x. So 14x plus 10x would be 24x. And then we've got minus 35 plus 20. And if we've got minus 35 and we add 20, we're going to go back up 20, so it's going to be minus 15. And then that's all over x plus 2 in one bracket and 2x minus 5 in the other bracket. And then that equals 3. So we've just added together what we had on the numerators. Okay, so we've now got this fraction equals 3. Let's multiply both sides of the equation by the denominator. So let's multiply the left-hand side by x plus 2, 2x minus 5. And let's multiply the right-hand side of the equation by x plus 2, 2x minus 5. So on the left-hand side of the equation, we're multiplying by the denominator to get rid of the denominator. So we're just going to be left with the numerator. So that's going to be 24x minus 15. And then that's going to be equal to, well, we've got 3, and then we're multiplying by these two brackets. So we just have 3, and then the brackets, x plus 2, 2x minus 5. Okay, so this is fantastic. We've now got an equation with nothing on the denominators, so we just need to solve this now. So let's actually go back up here and write it up here. So we've got, let's write it up here, 24x minus 15 equals 3 bracket x plus 2, and then 2x minus 5. Close brackets. Okay, now at this point there's a few different things we could do. One approach would be to expand the pair of brackets, so to expand these two brackets, then multiply everything by 3, and then to just solve that equation. Another approach would be actually, well, if you look here, we've got 24x minus 15. They're both divisible by 3, and on this right hand side we've got our two brackets, but we've also got this times by 3. So we could get rid of this times by 3 here by dividing both sides of the equation by 3. And that's actually the approach that I'm going to use. So I'm going to divide the left hand side of the equation by 3, and I'm going to divide the right hand side of the equation by 3. On the left-hand side of the equation, if I divide everything by 3, 24x divided by 3 would be 8x, and then minus 15 divided by 3 would be minus 5. That's what we get to divide everything there by 3. And then on the right-hand side of the equation, we had 3 times this times this. We're dividing by 3 to get rid of the times by 3, so we're just going to be left with our two brackets. That's going to be x plus 2, and then in brackets 2x minus 5. So we've got rid of that times by 3 by dividing both sides of the equation by 3. Now let's expand our brackets. So the left-hand side will stay the same, 8x minus 5. And then the right-hand side of the equation, we're going to expand our brackets here. So x times 2x would be 2x squared. X times minus 5 would be minus 5x. 2 times 2x would be plus 4x. And then finally, 2 times minus 5 would be minus 10. So we've expanded our brackets. Now let's simplify this right-hand side. So the left-hand side will stay the same, 8x minus 5. And the right-hand side, we've got our 2x squared. We've then got minus 5x plus 4x. And if we've got minus 5x's plus 4x's, we'll go back up. So it'll be minus 1x or just minus x. And then finally, we've got our minus 10. Okay, so we've expanded our brackets and we've simplified. Now if we have a look here, we've got a quadratic equation. So let's make it equal 0. So let's make this left-hand side 0. So we're going to take away 8x from both sides of the equation. So on the left-hand side, if we take away 8x's, we'll be left with minus 5. And then we've got on our right-hand side, we'll have our 2x squared. Minus x, take away another 8x's, will be minus 9x's. And then we've still got our minus 10. So we've just taken away 8x's from both sides of the equation. Now we want to get rid of this minus 5, so let's add 5 to both sides of the equation. So if we add 5 to the left hand side, we get 0. That's what we wanted. And on the right hand side, we're going to have 2x squared minus 9x. We have minus 10, we're adding 5, so we're going back up 5, so it'll be minus 5. Okay, fantastic. So we've now got this quadratic equation. Now let's factorize it, hopefully. It's an uncalculated question, so hopefully it factorizes. So 0 equals bracket, 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 bracket. It's 2x squared, so we're going to go for 2x and an x. And then we want the two numbers to multiply together to be minus 5. And when we expand our brackets, we want to get a minus 9x in the middle. So I'm thinking if we put a minus 5 there, that'll be 2x times minus 5 would be minus 10x's. And then a plus 1 there, because 1 times minus 5 would be minus 5. And if we expand these brackets, we would get that minus 9x in the middle. Okay, we're almost there. This bracket, we want it to equal 0, so x will equal 5. And then in terms of this bracket, we've got 2x plus 1. We want it to equal 0, so I'm just going to write down a little equation here. 2x plus 1 equals 0. Take away 1 and take away 1, so we're going to get the 2x equals minus 1. And then divide by 2, so we're going to get the x equals minus a half. That means that either x is equal to minus a half or x is equal to 5. And that's our answer, that x is equal to minus a half or x is equal to 5. And that's it. Okay, let's look at our next question, question number 6. Okay, so question number 6. Question number 6 is a calculator question, and we've been asked to give our answers to one decimal place. So that means that this question will probably get to a point where we're going to need to use the quadratic formula, and the calculator will help us do that. Okay, so we've got 1 over 2x plus 1 plus 4 over x minus 2 equals 1. So again, what we're going to do is we're going to simplify this left-hand side of the equation by adding together these two algebraic fractions. So we're going to multiply both the numerator and denominator of this fraction by x minus 2, and both the numerator and denominator of this fraction by 2x plus 1. Okay, so in terms of this fraction, we multiply both the numerator and denominator by x minus 2. The numerator is 1, so if we times that by x minus 2, we just get x minus 2. And in terms of the denominator, we had 2x plus 1. We're going to times that by x minus 2, so we'll just put them both in brackets and beside each other. Okay, then we've got our plus sign, and now we're going to multiply both the numerator and denominator of this fraction by 2x plus 1. So we've got our 4, and we're going to times that by 2x plus 1, so we're just going to put that in brackets. And then our denominator will be, well, we've got x minus 2, we're going to times it by 2x plus 1, so we're just going to put them in brackets beside each other, and I'm actually going to keep it the same way that this first fraction was, so I'm going to write it as 2x plus 1, and then in brackets x minus 2. Okay, so we've got our two fractions with the same denominators, and then that still equals 1. Okay, now before we add these fractions together, we want to expand this bracket on the top line, or this numerator of the second fraction. So the first fraction will stay the same, x minus 2, and then in brackets 2x plus 1, and then x minus 2. And then the second fraction, we're going to multiply out that bracket on the numerator. We're going to expand that bracket. 4 times 2x is 8x, and then 4 times 1 will be plus 4. So we've expanded the bracket on the numerator. The denominator will keep it the same, so that's 2x plus 1, and then in brackets x minus 2. And that all equals 1. Okay, so we've expanded our brackets there. Now we've got two fractions with the same denominator, so we can now just add the numerators together. So let's add the numerators. X plus 8x would be 9x's, because we've got an x plus 8x's would be 9x's. And then we've got minus 2 plus 4. So we've got minus 2 plus 4, and minus 2 plus 4 would be 2. If we're at minus 2 and we got 4, we get to 2, so plus 2. And then the denominator stays the same, so it's going to be 2x plus 1, and then in brackets x minus 2. And that whole thing equals 1. Okay, this is fantastic. Now actually, because this one equals 1, we know that the numerator is going to be the same as the denominator, so we can just put them equal to each other. Or if we wanted to, we can multiply both sides of the equation by the denominator here. So we can multiply by 2x plus 1, and then in brackets x minus 2, and likewise the right hand side of the equation by 2x plus 1 and x minus 2. So we're multiplying both the left hand side of the equation and the right hand side of the equation by the denominator. And when we do that, we'll be left with just the numerator here, the 9x plus 2, because we're multiplying by the denominator to get rid of the denominator. We don't want to divide by it, so we're multiplying by it to get rid of it. And then on the right hand side, we've got the 1 times by the two brackets. That'll just be the two brackets. And if you notice here, we've got the numerator equals the denominator, so they're just equal to each other. Okay, so now let's then solve this. So let's go up here where we've got 9x plus 2 equals, and I'm just going to make sure I get this right, 2x plus 1, and then in brackets x minus 2. Okay, this is fantastic. So now what we're going to do is we're going to expand these brackets. So let's do that. So the left hand side will stay as 9x plus 2. And then whenever we expand our brackets, what do we get? Well, we've got 2x times x, that's 2x squared. 2x times minus 2 would be minus 4x. 1 times x would be plus x, it would just be plus 1x. And 1 times minus 2 would be minus 2. So we've expanded our brackets. Now let's simplify this on the right hand side. So we've got 9x plus 2 equals 2x squared. We had minus 4x's plus 1x, so that's going to go back up 1x, that'll be minus 3x's. and then we've got minus 2. Now this is a quadratic equation. We want it to equal 0, probably to use the quadratic formula actually. So let's get rid of the 9x by taking away 9x's from both sides of the equation. So we're going to be left with, on the left hand side, 2 equals, and then we had 2x squared, so 2x squared. We're taking away 9x's, so if we had minus 3x's, take away another 9x's, that'll be minus 12x's, and then we've still got our minus 2. Okay, we want it to equal 0, so let's get rid of this 2 by taking away 2 from both sides of the equation. The left-hand side of the equation, we had 2, take away 2, that's 0, which is what we wanted. And then the right-hand side of the equation, we've got 2x squared minus 12x, and then we had minus 2, take away another 2 would be minus 4. Okay, we're almost there. We could use the quadratic formula at this point if we wanted to, but because everything on the right hand side is divisible by 2, we're going to divide the whole equation through by 2. So I'm just going to divide everything on the left hand side and the right hand side by 2. You could, if you wanted to, just use the quadratic formula at this point, but if we divide everything by 2, it's just going to give us slightly easier numbers to work with. So let's do that. So if we do 0 divided by 2, that's 0. And then on the right hand side, we divide everything by 2, so that'll give us x squared minus 6x minus 2, just dividing everything by 2 there. Now, it's a calculator question, so I'm guessing this doesn't factorize, so I'm not even going to try it because it says to give our answers to one decimal place. So what I'm going to do now is I'm going to use the quadratic formula, and I'm actually just going to scroll down a bit just to give us a bit more room here. So I'm actually going to write this down here and use the quadratic formula down there. So here we've got 0 equals x squared minus 6x minus 2. So that means that a, the coefficient of the x squared, would be 1. There's a 1x squared, so 1. B is equal to the coefficient of x, the number in front of the x, which would be minus 6. And C is the constant on the end, so it's going to be minus 2. So we know what A, B, and C are. And let's write down the quadratic formula. Now remember, it is given to you, so you can just look it up in the formula sheet. But the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so that's the quadratic formula. Now we're going to substitute in those values. So we're going to substitute in a is equal to 1, b is equal to negative 6, and c is equal to negative 2. So let's do that. Okay, so x equals negative b. Well, b was negative 6. So we've got negative 6. So that's just going to be 6. And then we've got plus or minus the square root of b squared. So it's going to be minus 6 squared, just putting the minus 6 in a bracket there, and then squared, and then minus 4ac. I like to put this all in a bracket here, so 4 times a, which is 1, times c, which is negative 2, and then close brackets, and then that's all divided by 2a, and 2 times 1 would be 2. 2 times a, 2 times 1 is 2. Okay, so we're almost there. I'm just going to do a little bit of simplifying before I get my calculator. So x equals 6 plus or minus the square root of minus 6 squared. Well, minus 6 times minus 6 is 36. So it's going to be 36 minus. And then let's work out our bracket. 4 times 1 times minus 2. 4 times 1 is 4. Times minus 2 would be minus 8. And then close brackets. And that's all divided by 2. Okay, now at this point you could just get your calculator, but I'm just going to simplify what's under the square root. So we've got 6 plus or minus the square root of 36 minus 8. So it's going to be 36 plus 8, which is 44. And that's all divided by 2. So that means that x would be equal to 6 plus the square root of 44 divided by 2, or x equals 6 minus the square root of 44 divided by 2. So let's work those out and see what we get. So x would be equal to, and I'm just going to get my calculator and type this in. So that means that x would be equal to 6.3166 and so on, or x would be equal to minus 0.3166 and so on. And we've been asked to give our answers to one decimal place. So here x would be equal to 6.3, or here x would be equal to minus 0.3. So we've rounded those to one decimal place, and we've got our answers that x is equal to 6.3, or x is equal to minus 0.3. So let's write that down. X equals 6.3, or x equals minus 0.3. And there are two solutions, and that's it. Okay, let's get our next question, question number 7. So question number 7 says solve, given your answers to two decimal places. So we've been asked to solve this equation, we need to give our answers to two decimal places. And it's a calculator question, so we're probably going to be using the quadratic formula there. Okay, so we want to add together these fractions on the left-hand side, so let's give them the same denominator. So let's find a common denominator. So we're going to multiply both the numerator and denominator of this fraction by x plus 4, and we're going to multiply both the numerator and denominator of this fraction by x plus 1. So that will be, if we times both the numerator and denominator of this fraction by x plus 4, we would get 5, and then in brackets x plus 4, close brackets, all over, and then we had x plus 1, but we're now timesing that by x plus 4. Okay, so we've times both the numerator and denominator of this fraction by x plus 4. Now what we want to do is multiply both the numerator and denominator of this fraction by x plus 1. So that will be 3, and then in brackets x plus 1, close brackets, and then the denominator will be x plus 1, and then in brackets x plus 4. So we've now got our two fractions with the same denominator, so we've found that common denominator, and that equals 2/3. So now what we're going to do is we're going to expand the brackets on the numerators. So in terms of the first fraction, 5 times x would be 5x, and then plus, and 5 times 4 is 20, and then we've still got that same denominator of x plus 1, and then in brackets x plus 4, close brackets, and then plus, and let's expand the brackets on the numerator here. So 3 times x is 3x, and 3 times 1 will be plus 3, and that's still over x plus 1, and then in brackets x plus 4. So we've now got our fractions with the same denominators, and we've expanded our brackets. Now what we're going to do is we're going to add together the numerators. So 5x plus 3x would be 8x, and 20 plus 3 would be plus 23. And then we've still got that denominator of x plus 1, and then in brackets x plus 4. And we've got that's equal to 2/3. Okay, we're getting there. Now at this point we want to get rid of these x's on the denominator here. So what we could do is we could multiply both sides of this equation by our x plus 1, x plus 4. And then also what we could do is we could multiply both sides of the equation by 3 to get rid of this 3 in the denominator. Or another way to do it would be to watch the Corbettmaths video on cross multiplication. If you've got a fraction equals another fraction, you can multiply the numerator of one fraction by the denominator of the other fraction, and that's equal to the other numerator times the other denominator. So in other words, 8x plus 23 multiplied by 3 will be equal to 2 times x plus 1 times x plus 4. So you can just multiply the numerator by the denominator and put that equal to the other numerator times the denominator, and that's called cross multiplication, and it works if you've got a fraction equals a fraction. And you could try it out with some equivalent fractions. You could perhaps get a fifth and then write that's equal to 3/15, because they're equivalent fractions, and if you multiply that numerator by that denominator you get 15, and if you do 3 times 5 you get 15 as well. So that works. Okay, so that's what I would tend to do if I had a fraction equals a fraction. I use cross multiplication, so I would do this times 3, so I'd have 3 bracket 8x plus 23, and then close brackets, and then put that equal to 2, and then our two brackets here, x plus 1, and then x plus 4. So that's one way you could do it, use cross multiplication. Or another way, like I mentioned, was to just multiply both sides of the equation by the denominator here, and then multiply both sides of the equation by that denominator, and that would work as well. Okay, so now what we're going to do is we're going to expand our brackets. So on the left hand side, 3 times 8x would be 24x, and 3 times 23 would be plus 69, and that equals, and then here we're going to have our 2, and let's expand our brackets here and see what we get. So x times x is x squared, x times 4 would be plus 4x, 1 times x would be plus x, and then 1 times 4 would be plus 4. Okay, and now let's simplify this. So we're going to have 24x plus 69 is equal to 2, and then in brackets x squared. We'll go 4x plus x, that's plus 5x, and then plus 4, and then close brackets. So we've simplified this. Now let's expand our brackets here. So we've got 24x plus 69 is equal to, and expanding this would be 2x squared plus 10x plus 8. Okay, now we're getting there. Let's make this left-hand side of the equation 0. So let's take away 24x from both sides and take away 69 from both sides of the equation. So we're going to get 0 on the left-hand side here. And then the right-hand side, if we take away 24x and 69, well, the 2x squared will stay the same. We had 10x, we're taking away 24x, that'll be minus 14x. And we had 8, we're taking away 69 from that side, so that'll be minus 61. Okay, so we've now got this, that's a quadratic equation, 2x squared minus 14x minus 61 equals 0. And we want to solve that, and then we'll find our values for x. Now remember, the question did say to give our answers to 2 decimal places, and when we look at this it probably doesn't factorize. So let's write down our values for a, b and c and use the quadratic formula. So a would be equal to 2, b would be equal to minus 14, and c would be equal to minus 61. So we've got our values for a, b and c. Let's write down the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so that's the quadratic formula. Now let's substitute our values and work it out. So if we substitute our values, let's see what we get. So minus b, so x equals minus b, b's minus 14, minus 14 would be 14, plus or minus the square root of b squared, well, it's going to be minus 14 squared, and if you do minus 14 squared on your calculator, you get that's equal to 196, minus, and then I'm going to put this bit in brackets, 4 times a, which is 2, times c, which is minus 61. And then close brackets. And that's all divided by 2a. A is equal to 2. 2 times 2 would be 4. Okay, so now let's work this out. X equals, we've then got 14 plus or minus the square root of, and I'm just going to work this part out in my calculator. I'm going to get my calculator, I'm going to do 169 minus, and then in brackets, 4 times 2 times minus 61, and close brackets. That's equal to 684. And that's all divided by 4. Okay, now we're almost there. I'm going to go back up here now. So that means that x would be equal to 14 plus the square root of 684, all divided by 4, or x equals 14 minus the square root of 684, all divided by 4. Okay, so we've now got our two solutions. Let's work them out in our calculator. So x equals, and if we do this on our calculator, we get, and when we work this out, we get an answer of 10.0383 and so on. Or when we work this one out, we get an answer of minus 3.038 and so on. And we've been asking the question to give our answer to two decimal places. That means that here either x would be equal to 10.0, and we had 38, so we're going to round up, so that'll be 4. Or here we're going to have x equals minus and then 3.0 and then 38, so we're going to round up to 4. So that means that x will be equal to 10.04, or x would be equal to minus 3.04 to two decimal places. And that's it, we've solved that question. Okay, let's have a look at our next question, question number 8. So question number 8 says to solve 1 over x plus 1 plus 2 over x equals 5. And we need to give our answer in the form of p plus or minus the square root of q over 5, where p and q are integers. Okay, so what I'm going to do is I'm going to start by adding together these two fractions on the left-hand side of the equation. So write that as a single algebraic fraction. So let's multiply both the numerator and denominator of this fraction by x, and both the numerator and denominator of this fraction by x plus 1. So if we multiply by the numerator of this fraction by x, 1 times x is just x. And then the denominator, if we've got x plus 1 and we times it by x, well, we'll just have x and then in brackets x plus 1, just putting them together. And I'm going to put the x in front of the x plus 1 because that's just how I tend to write that. I wouldn't tend to write x plus 1 in brackets and then the x afterwards, tend to bring the x in front, like a bit like I do with the numbers. Okay, and then we've got plus, and then we've got 2 over x. We're going to multiply both the numerator and denominator of that fraction by x plus 1. So 2 times x plus 1 will be 2 bracket x plus 1. And then we've got x, and we're going to times it by x plus 1, so it'll be x bracket x plus 1. And that equals 5. Okay, so we've now got two fractions with the same denominators. Let's now expand the brackets here. So our first fraction will stay the same, x over x bracket x plus 1, close brackets. And then we've got plus, and now let's expand these brackets. 2 times x would be 2x, and 2 times 1 is 2, so plus 2. And that's all over x bracket x plus 1, close brackets, and that equals 5. Okay, so now we've got two fractions with the same denominators. Let's add together the numerators. So x plus 2x is 3x, and then we've still got our plus 2. And that's all over x bracket x plus 1, and then close brackets, and that equals 5. So, and we've just added together the numerators there. X plus 2x is 3x, and then we've still got our plus 2. Okay, we're getting there. Let's get rid of this denominator. So let's multiply both sides of the equation by x bracket x plus 1, and then the left and the right hand side by x bracket x plus 1 as well as the left hand side. So on the left hand side, we're timesing by the denominator to get rid of the dividing by the denominator, so just going to be left with the numerator, so that's going to be 3x plus 2. And on the right hand side of the equation, we've got 5, and we're going to times it by x bracket x plus 1, so we end up with 5x bracket x plus 1. Just put them together. Okay, now let's expand the brackets and get a quadratic equation. So we've got 3x plus 2, and then on the right hand side, 5x times x is 5x squared, and 5x times 1 will be plus 5x. Okay, so it's now beginning to look like our quadratic equation. Well, let's get it to equal 0. So let's take away 3x's from both sides. So on the left-hand side, we'd just be left with 2. And on the right-hand side, if we take away 3x's, we'd be left with 2x's. So that's just taking away 3x's from both sides of that equation. And finally, let's take away 2 from both sides. So we'd end up with 0 equals 5x squared plus 2x. And then we've got that minus 2 on the end. And that's it. Okay, so we've now got our quadratic equation. Now we want to get it in the form of p plus or minus the square root of q all over 5. And it's a non-calculator question. But actually this looks a bit like what we get whenever we use the quadratic formula. So what I'm actually going to do is I'm going to write down what a, b and c are for the quadratic equation we've got. And then I'm actually going to substitute them into the quadratic formula and see if we can get something in this form. So let's do that. So we have got this quadratic. I'm going to let a equals 5, b equals 2, and c equals negative 2. Okay, let's write down the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac. B squared minus 4ac. I'm just going to make that b look a little bit better. All divided by, better, that's still a b, 2a. Okay, so if that's the quadratic formula, let's substitute in our values. So x equals negative b, well b is equal to 2, so it's going to be negative 2. So negative 2 plus or minus the square root of, and then we've got b squared, so 2 squared is 4, minus, and then I like to put this bit in a bracket, so bracket, and then 4 times a, which is 5, times c, which is negative 2. Okay, and that's all divided by 2a, and a is equal to 5, so 2 times 5 is 10. Okay, so now let's work out what's under the square root. So x equals negative 2 plus or minus the square root of, so we've got 4 and then minus, and let's work out what's in the bracket. 4 times 5 is 20, times minus 2 would be minus 40, close brackets, and that's all divided by 10. Okay, we're getting there. Let's just simplify this a bit more. So we've got x equals negative 2 plus or minus the square root of 4 minus minus 40. Well, that'll be 4 minus minus 40 would be 44, all divided by 10. Now this is what we've got. Let's go back up and see what we're trying to find. P plus or minus the square root of q over 5. So we want it to be over 5. So if we have a look here, we've got this is over 10. So actually what I'm going to try to do is I'm going to try to simplify this third, because perhaps this third can be simplified. So x would be equal to the minus 2 plus or minus. Now in terms of this third, the square root of 44, I'm just going to go over here. The square root of 44, well the biggest square number, think back to simplifying thirds. To simplify a third, you look for the biggest square number that's a factor of the number. So that's going to be, in this case, just 4. So the square root of 4 times the square root of 11. And the square root of 4 is 2, so it's going to be 2 times root 11, or 2 root 11. So root 44 is 2 root 11. And that's all divided by 10. Now we're almost there, because if we go back up to see what we're trying to get, we wanted it in the form where we have a number plus or minus the square root of a number over 5. So what I'm going to do is I'm going to simplify this fraction. I'm going to divide both the numerator and denominator of the fraction we've got by 2, because we've got 10 on the denominator, so if we half everything on the numerator and the denominator, we'll get an equivalent fraction. So in terms of the numerator, if you divide everything by 2, well minus 2 divided by 2 would be minus 1. Plus or minus, and then we've got 2 lots of root 11. If you divide 2 lots of root 11 by 2, you just get 1 lot of root 11, or just root 11, and then all divided by, and half of 10 is 5. So that's it. X equals negative 1 plus or minus the square root of 11 over 5. And that's it. And that's in the format that we were trying to get it in. So we've got minus 1 plus or minus the square root of 11, all divided by 5. And that's it. Okay, let's look at the next question, question number 9. So question number 9, we've been asked to solve 9 over 4x minus 1 equals 4 sevenths plus 3 over x plus 2. Okay, so I'm going to add together these fractions on the right hand side of the equation. So we've got 9 over 4x minus 1 on the left hand side of the equation. And on the right hand side of the equation, we want to get a common denominator. So we're going to multiply both the numerator and denominator of this fraction by x plus 2, and both the numerator and denominator of this fraction by 7. Okay, so multiplying both the numerator and denominator of this fraction by x plus 2 would be 4 bracket x plus 2, close brackets, and then over 7 bracket x plus 2. Just multiplying both of those by x plus 2. Okay, and then plus. Now we're going to multiply both the numerator and denominator of this fraction by 7. So 3 times 7 is 21 over, and then we're going to multiply this by 7, so it's going to be 7 brackets x plus 2. Okay, so we've now got two fractions with the same denominators. So let's expand the brackets on the numerator so we can simplify them. So on the left hand side, we've got 9 over 4x minus 1. And on the right hand side, 4 times x is 4x. 4 times 2 is 8, so plus 8. And then over 7 bracket x plus 2. And then actually, there's nothing to expand on this one because it's just 21 over 7x plus 2. Okay, so we've expanded the brackets there. Now what we're going to do is we've got two fractions with the same denominators, so we're going to add the numerators. So the left hand side will stay as 9 over 4x minus 1. And the right hand side, in terms of the numerators, if we add them, we've just got 4x's, so it'll be 4x's. And then 8 plus 21 will be 29, so plus 29. And that's over 7 bracket x plus 2, close brackets. Okay, so we've added together the numerators there on this right hand side, and we've now got a single fraction. Okay, now if we have a look at this, we've now got a fraction equals a fraction. There's a few different approaches we could use here. One approach would be to multiply both sides of the equation by 4x minus 1, and then to multiply both sides of the equation by 7 bracket x plus 2. And then what you'd end up with would be 9 times this and 4x plus 29 times that, and then you can solve that. And a quicker way of doing that is just using cross multiplication, where you say if you've got a fraction equals a fraction, that this numerator times that denominator is equal to that numerator times that denominator. So rather than doing it in 2 steps and timesing both sides of the equation by that, and then timesing both sides of the equation by that, we can just do it in 1 step. So we've got 9 times this, so 9 times 7 brackets x plus 2 would be 9 times 7 is 63, so we'd have 63 and then in brackets x plus 2, just multiplying the 9 and the 7 together and putting the bracket after it. And then on the right hand side of the equation, we're going to be timesing these two together, so we're going to put them in brackets. We've got 4x plus 29, but we're also going to be timesing that by 4x minus 1. Okay, so we've done that numerator times that denominator and that numerator times that denominator and put them equal to each other. Okay, now let's expand our brackets. 63 times x would be 63x, and then 63 times 2 would be 126. Then on the right hand side of the equation, 4x times 4x is 16x squared. 4x times minus 1 would be minus 4x. 29 times 4x, well, this is a calculator question, so I'm just going to quickly do my calculator. That's 116, so plus 116x. And then 29 times minus 1 is minus 29. Okay, so we've now got to this point. Let's simplify these. So minus 4 plus 116, or minus 4 plus 116 is 112. So we're going to get 63x plus 126 equals 16x squared plus 112x minus 29. Now, for a quadratic equation, we often like it to equal 0, so let's make it equal 0 by taking 63x away from both sides, so taking away 63x from both sides of the equation. On the left-hand side, we'll be left with 126, and on the right-hand side, we'd have 16x squared plus, and then on my calculator, I'm going to do 112, take away 63, and that's equal to 49x, and then minus 29. And then finally, we want to get rid of this 126. So if we take away that from both sides of the equation, we'll be left with 16x squared plus 49x. And then if we have minus 29 and we take away another 126, that's equal to minus 155. Okay, so this is fantastic. We've now got a quadratic equation. Now, I'm not really excited about this because I'm looking at this quadratic equation and thinking it looks pretty horrible. The fact it's 16x squared. In terms of factorizing, if we had 16x squared and we tried to factorize, we can end up with a 16x and an x. It could be 8x and 2x. It could be a 4x and a 4x. And I do know that this question factorizes. However, it's a calculator question. So if I had this and I was probably in an exam and I had a limited amount of time, I might be tempted to use the quadratic formula just in the interest of time. You could use the split in the middle technique as well if you wanted to use that, but I'm going to, for this one, I'm going to use the quadratic formula, but then I'll show you that it factorizes as well. Okay, so in terms of the values for a, b, and c, a is going to be equal to 16, b is going to be equal to 49, and c is going to be equal to minus 155. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So that's the quadratic formula, and if we substitute our values, minus b will be minus 49 plus or minus the square root of b squared, so that's 49 squared, that's equal to 2401, minus 4ac, so it's going to be 4, and I'm going to put it in brackets, 4 times a times c, so 4 times 16 times minus 155 is equal to minus 9,920, close brackets. And that's all divided by 2a, and 2 times 16 is 32. Okay, so we've now got to this point. I'm going to go up to here. X would then be equal to minus 49 plus or minus the square root of, and then we've got 2,401 subtract minus 9,920 is equal to 12,321, and that's all divided by 32. Now, that's actually a square number. If we square root 12,331, you actually get that's equal to 111. So we end up with x is equal to minus 49 plus or minus 111, because that is a square number. And then if you divide that by 32, then that'll give you your solutions. So either the x is equal to minus 49 plus 111 over 32, or x is equal to minus 49 minus 111 over 32. So let's work with both of these out and see what we get. So minus 49 plus 111 divided by 32 is equal to 31/16, or x would be equal to minus 5. So there are two solutions. So either x is equal to 31/16 or x is equal to minus 5. There are two possible solutions, and that's it. Okay, and I just want to point out that obviously you may have factorized this, and actually we can probably cheat using our answers, that if these are the answers you could work backwards and think what the brackets would be. So at this point here you could have factorized and said 0 equals, because we've got a 16 there, we know it's going to be a 16x and an x. And this one's going to be plus 5, and this one's going to be minus 31. And if you expand these brackets, you'd get that, and then you'd be able to find the answers. But that would have been quite tricky to factorize something like that with quite large numbers. And that's it. So that's that question answered. Okay, let's look at our next question. Question number 10. So question number 10 says to solve, given your answers to one decimal place, x over 1 plus 4x plus 3 over x minus 1 equals 2. So we want to solve this. It's a calculator question, and we've been asked to give answers to one decimal place. So I'm going to guess that we might be using the quadratic formula in this question. So let's add together these fractions on the left-hand side of the equation. So we're going to multiply both the numerator and denominator of this fraction by x minus 1, and both the numerator and denominator of this fraction by 1 plus 4x. So if we multiply both of the numerator and denominator of this fraction by x minus 1, we would get x, and then in brackets, x minus 1. And then in terms of the denominator, we would have 1 plus 4x, and then we're going to times that by x minus 1. So we're just multiplying both the numerator and denominator of this fraction by x minus 1. And then plus, and we're going to multiply both the numerator and denominator of this fraction now by 1 plus 4x. So that'll be 3, and then in brackets 1 plus 4x. And then in terms of the denominator, we're going to multiply x minus 1 by 1 plus 4x. We could write x minus 1 and then in brackets 1 plus 4x, but I'm going to write it the other way around to match this denominator here. So 1 plus 4x brackets x minus 1. And that equals 2. Okay, now let's expand our brackets on the numerator. X times x is x squared. And then we've got x times minus 1 be minus x. And then that same denominator, 1 plus 4x, and then in brackets x minus 1. And then our other fraction, we're going to expand the brackets here. 3 times 1 is 3, and 3 times 4x is 12x. And then that's still over 1 plus 4x, and then in brackets x minus 1. And then that equals 2. Okay, now let's add together these fractions. So let's add together the numerators. Okay, let's add together the terms of x squared. That's just going to be x squared. Then we've got minus x plus 12x. Minus x plus 12x will be 11x's, so plus 11x. And then we've got just add 3, so add 3. And that's all over 1 plus 4x, and then in brackets x minus 1. And then that equals 2. Okay, so we've now got to this point here. We want to solve this, so let's multiply both sides of this equation by the denominator. So we're going to multiply the left-hand side by 1 plus 4x brackets x minus 1, and the right-hand side by 1 plus 4x brackets x minus 1. Okay, so in terms of the left-hand side of the equation, we're multiplying by this to get rid of it on the denominator. So we're just going to be left with x squared plus 11x plus 3. And then on the right-hand side of the equation, we've got 2, and we're timesing it by this, so this is going to be 2 brackets 1 plus 4x brackets x minus 1. Okay, so that's fantastic. We've now got rid of the denominator. We can now just expand our brackets, bring everything over to one side, and then probably use the quadratic formula. Okay, so let's expand the brackets here on the right-hand side. So on the left-hand side, it'll stay the same. And on the right-hand side, let's expand the pair of brackets first of all. So 1 times x would be x, 1 times minus 1 would be minus 1, 4x times x would be plus 4x squared, and 4x times minus 1 would be minus 4x. Okay, now let's simplify what's in the brackets. So it's going to be x squared plus 11x plus 3 equals 2, and then in brackets we've got our 4x squared. We're just going to put the x squared term in the front. We've then got x minus 4x, and x minus 4x be minus 3x's, and then we've got minus 1. Okay, so we're nearly there. We just need to expand the brackets now and bring everything over to one side. So x squared, and then use the quadratic formula, plus 11x plus 3 equals, and then if you times everything in the brackets by 2, you're going to get 8x squared minus 6x minus 2. Okay, so we're going to probably be using the quadratic formula in this question, so we want it to equal 0, so let's take away x squared, 11x, and 3 from both sides of the equation. So the left-hand side will be left with 0. On the right-hand side, 8x squared, take away x squared, will be 7x squared. Minus 6x, take away 11x, would be minus 17x. And minus 2, take away 3, would be minus 5. Okay, so it's fantastic because now we know that a is equal to 7, b is equal to minus 17, and c is equal to minus 5. We can use the quadratic formula. So let's do that. I'm going to go up here. A is equal to 7, b is equal to minus 17, and c is equal to minus 5. Okay, so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so that's the quadratic formula. Let's substitute in the values for a, b, and c into the quadratic formula. So x equals negative b, so that's negative minus 17 or minus 17, so it's going to be 17, plus or minus the square root of b squared, that's going to be minus 17 squared, so minus 17 times minus 17 is 289, minus 4ac, so that's going to be brackets 4 times a, which is 7, times c, which is minus 5. And that's all divided by 2a. And 2 times a, 2 times 7 is 14. So that means that x equals 17 plus or minus the square root of, and I'm just going to type this bit into my calculator, 289 minus, and then in brackets 4 times 7 times minus 5, close brackets, is equal to 429, all divided by 14. Okay, so that means that either x is equal to 17 plus the square root of 429 over 14, or 17 minus the square root of 429 over 14. So let's write those out. 17 plus the square root of 429 over 14, or x equals 17 minus the square root of 429 over 14. So let's work this out. So x equals, if we do 17 plus the square root of 429, and divide that by 14, we get that's equal to 2.693 and so on. Or here, x is equal to, if we do 17 minus the square root of 429 divided by 14, we get that's equal to minus 0.265 and so on. And we want to round these answers to one decimal place, so that means that here x would be either equal to, x is equal to 2.7, or here x is equal to minus 0.3. So there are two solutions, the x equals 2.7 or x equals minus 0.3, and that's it. Okay, let's look at our next question, question number 11. So question number 11, we've been asked to solve and to give our answers to one decimal place the equation 2x minus 1 over x minus 4 over x plus 2 equals 5. Okay, so let's multiply both the numerator and denominator of this fraction by x plus 2 and both the numerator and denominator of this fraction by x and see what we get. So in terms of this fraction, if we times both the numerator and denominator by x plus 2, the numerator will become 2x minus 1 and then in brackets x plus 2. And then the denominator, we had x, we're timesing it by x plus 2, so it'll just be x brackets x plus 2. And then here we've got our minus, and then we're going to times both the numerator and denominator of this fraction by x. So 4 times x is 4x, and then our denominator, we had x plus 2, we're timesing it by x, it'll be x bracket x plus 2. And then that equals 5. Okay, so we're almost there. We've got the same denominators. Let's expand the brackets here on this numerator. So 2x times x would be 2x squared. Okay, then we've got 2x times 2, that's plus 4x. Minus 1 times x, that's going to be minus x. And minus 1 times 2 would be minus 2. So we've expanded the brackets there. It's still over x bracket x plus 2. And then close brackets. And then minus 4x over x bracket x plus 2. And then that equals 5. Okay, let's simplify this numerator here. So in terms of simplifying this numerator, we'd have 2x squared. And then we've got 4x's, take away an x. That's going to be plus 3x's. And then minus 2. And that's over x bracket x plus 2. And then we're going to take away 4x over x bracket x plus 2. And that equals 5. Okay, so we've now got our two fractions with the same denominator, so let's take them away. So 2x squared, well, we're not taking anything away, so it's going to be 2x squared. 3x, take away 4x. Well, 3x's, take away 4x's would be minus 1x, or just minus x. And then we've got our minus 2. And that's all over x bracket x plus 2. Close brackets, and that equals 5. Okay, so we've now got to this point. Well, we want to solve this equation, so let's get rid of the denominator. So let's multiply both sides of the equation by x bracket x plus 2. So multiply by x bracket x plus 2 and multiply by x bracket x plus 2. So the left-hand side will just be left with 2x squared minus x minus 2. And the right-hand side, we're going to have 5x bracket x plus 2. And we've just multiplied both sides by the denominator there, and this is what we've got. Okay, now let's expand our brackets. I'm just going to scroll down a little bit here. So we're going to have 2x squared minus x minus 2 equals 5x times x is 5x squared, and 5x times 2 would be plus 10x. Okay, so now we've got our quadratic equation. We want it to equal 0, so I'm going to bring everything to the right-hand side of the equation so that we're left with 0 on the left-hand side. 5x squared, take away 2x would be 3x squared. 10x, add x would be plus 11x, and then we're going to be adding 2, so it'll be plus 2. So we've now got our equation, our 0 equals 3x squared plus 11x plus 2. Okay, so A would be equal to 3, B is equal to 11, and C is equal to 2. So we're going to use the quadratic formula, and we're going to use those values for A, B, and C. So A is equal to 3, B is equal to 11, and C is equal to 2. Okay, so let's write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And if we substitute in the values, x equals negative b, so it's going to be minus 11, plus or minus the square root of b squared, that's going to be 121, minus, and then I like to put this bit in a bracket, 4 times a times c. So 4 times a, which is 3, times c, which is 2, is equal to 24. And that's all divided by 2a, and 2 times a, 2 times 3 is 6. And then if we simplify what's under the square root, we're going to get minus 11 plus or minus the square root of 121 take away 24 is equal to 97 all over 6. So that means that x is equal to minus 11 plus the square root of 97 divided by 6, or x is equal to minus 11 minus the square root of 97 divided by 6. So let's work these out and see what we get. So x would be equal to minus 0.1918 and so on, or x is equal to minus 3.47 and so on. And we've been asked to give our answers to one decimal place. So to one decimal place, that means that x would be equal to negative 0.2, or x is equal to minus 3.5. So there are two solutions. So x equals minus 0.2, or x equals minus 3.5, and that's it. Okay, let's have a look at our last question, question number 12. So question number 12, we've been asked to solve and to give our answers to two decimal places. So again, a calculator question, answers to two decimal places, I'm thinking quadratic formula. We're going to simplify the left-hand side here. So we've got these two algebraic fractions and we're taking them away. So let's give them the same denominators and then take away the two fractions. So let's multiply both the numerator and denominator of this fraction by x plus 1, and both the numerator and denominator of this fraction by x plus 5. So in terms of this fraction, if we times them both by x plus 1, we would get x minus 4 in brackets and then x plus 1 in brackets, we're timesing them together, over x plus 5, then in brackets x plus 1. Okay, so that's what we get if we times both the numerator and denominator of that fraction by x plus 1. We've then got minus, and then we're going to multiply both the numerator and denominator of this fraction by x plus 5. So we're going to have 3x minus 2, brackets x plus 5, and then we could write x plus 1 and then x plus 5, but I'm going to write it this way around. So it's x plus 5 and then x plus 1, just to match up with the other one. And that equals 1. Okay, now what I'm going to do is I'm going to expand the brackets on the numerators. So I'm going to expand these brackets and I'm going to expand these brackets. So expanding these brackets, x times x is x squared. X times 1 is x, and then minus 4 times x is minus 4x. X minus 4x would be minus 3x. You could expand those brackets over here somewhere and then just write it there, just rather than writing the whole thing out again. Obviously also with these questions, they're quite complicated and you should be able to expand brackets like that quite easily. Minus 4 times 1 then would be minus 4. So we've expanded the brackets on the numerator, and the denominator we're going to keep it as it is, x plus 5, and then in brackets x plus 1. Okay, our next fraction, we're going to expand the brackets on the numerator. 3x times x would be 3x squared. 3x times 5 would be 15x, and minus 2 times x would be minus 2x. 15x's minus 2x's would be plus 13x's. Again, you could do this expansion to the side if you wanted to. And minus 2 times 5 would be minus 10. So just expanded those brackets there. And then in terms of the denominator, we'll keep that in brackets just because it's a bit easier to write it like that. And that equals 1. Okay, now, this is the bit where this question you've got to be a bit more careful than some of the others, because we've got a fraction take away a fraction. So we're going to do x squared take away 3x squared. And x squared take away 3x squared would be minus 2x squared. We've then got minus 3x minus 13x's. And if you've got minus 3x's and you take away 13x's, you're going to have minus 16x's. And then finally, minus 4 minus minus 10. So you've got minus 4, minus minus 10 means you're going to be adding 10. So if you're minus 4 and you're going to go up 10, you're adding 10, you're going to get to 6, so plus 6. So you've got to be careful with that subtraction there. X squared take away 3x squared would be minus 2x squared. Minus 3x, take away 13x would be minus 16x's, and minus 4 minus minus 10 would be 6. And that's all divided by x plus 5, x plus 1, and that equals 1. Okay, so we've now got our algebraic fraction. It equals 1. So actually at this point, you can say the numerator equals the denominator and then just solve that equation. Or you could times both sides of the equation by the denominator here. And when you do that, you're going to get the numerator, which is minus 2x squared minus 16x plus 6. And then if you multiply both sides by this, you're getting rid of it on the left-hand side. And then 1 times that would be just the brackets x plus 5, x plus 1. Or, as I said, put the numerator equal to the denominator because it just equals 1. Okay, now we want to solve this equation, so let's expand these brackets on the right-hand side. So we've got minus 2x squared minus 16x plus 6. And then on the right-hand side, if we expand the brackets here, x times x is x squared. X times 1 is x, or 1x, and 5 times x would be 5x. Add them together would be 6x. And then 5 times 1 is plus 5. Okay, so we've now got this. We just need to bring everything over to one side. I'm going to bring everything to the right-hand side because here we've got x squared and minus 2x squared. If we bring everything to the right-hand side, we'll just be left with 3x squared here on the right-hand side. So let's make the left-hand side 0. Bringing everything over to the right-hand side, well, we're going to add 2x squared, or add 2x squared to both sides. So you add it here, will be 3x squared. You want to bring this to the other side, so you're going to add 16x's to both sides. So you're going to add it on to our 6x, which would be plus 22x. And then taking away 6 would be minus 1. So we've now got the 0 equals 3x squared plus 22x minus 1. Now remember the question wanted the answers to 2 decimal places, so we're going to probably be using the quadratic formula here. A equals 3, B equals 22, and C equals minus 1. So the quadratic formula is x equals negative b, so negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's substitute in the values. Minus b, well, it's going to be minus 22, so minus 22, plus or minus the square root of b squared, that's 22 squared. 22 squared equals 484, minus, then in brackets, 4 times a times c, so 4 times 3 times minus 1 is equal to minus 12, close brackets. That's all divided by 2a, so 2 times 3 is 6. Okay, so we've now got this. Let's now work out what it would be under the square root. So you've got 484 minus 12, so that means add 12 on, so it'd be 496. So x is equal to minus 22 plus or minus the square root of 496, all divided by 6. Okay, so here we're going to have x equals minus 22 plus the square root of 496 divided by 6, or x equals minus 22 minus the square root of 496 divided by 6. It's just important in questions like this to give yourself enough room. So if you haven't got enough room on the page to do this, remember in the exam you're actually entitled to get more paper, so you can actually get some more paper, and it can be attached to the exam booklet if you wanted to. To be honest though, they probably will have given you enough room. So really what I should have done there is, and I'm actually going to demonstrate here, I should have just moved me around across the page like that. No, what I should have done actually was to actually just give myself more room to begin with. Okay, so we'd have minus 22 minus the square root of 496, all divided by 6. And when we work that out, we get an answer of 0.045176 and so on. Or here we get x is equal to, that's equal to minus 7.3785 and so on. And we want to give our answers to 2 decimal places. So here x would be equal to 0.05, rounding up, and here x is equal to minus 7.38. And that's it. There are 2 solutions. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on solving advanced fractional equations. With this particular topic, I highly recommend lots of different other topics. There would be adding and subtracting algebraic fractions, so make sure you're confident with algebraic fractions and adding and subtracting algebraic fractions. Also make sure you're confident with factorizing, expanding brackets, the quadratic formula. Even there was one question where we dealt with surds as well. So there's lots of different things that would be quite useful for this particular topic. If you need any extra help on this topic and you need to see more examples, go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 111A. Alternatively, also watch those other videos that I mentioned, the factorizing, the expanded brackets, the quadratic formula, algebraic fractions and things like that. I might have said that already. Also, you can scan this QR code. But in this video, I went through the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.